Good afternoon, everyone. I'm Thomas Anthony. I'm the co-founder and CIO of Analytical AI. Our topic today is securing from the curb to the gate. Well, we are an SVIP portfolio company. We have multiple SVIPs, and I have 5 minutes to speak about both. So we have one which is the phase 4, which is under the object recognition call, and we have our second SVIP, which is under the securing soft targets area, which we are currently in contracting with. Allison spoke this morning about the price challenge. That's how we got into the homeland security space. We were among the winners of the passenger screening algorithm challenge, and that's how we got into the space. And SVIP was our first OTA or our first interaction with the government. Today, we work with a lot of 3-letter agencies. We have 4 contracts with DHS, both with TSA and CBP. We work with the DoD, we work with Air Force and Army, we work with Sandia National Labs, we work with OEMs, and we have algorithms in deployment at the CBP. So these are our 2 topics that we're talking about, but we have a lot of other programs and ATRs as well, and our base is making the world a safer place. So let's see if the video starts playing. Yeah, all right, so this is what we call our property algorithmic screening system. This is complementary to what we build for prohibited items and explosive system. This is for the stream of commerce items that Ron was mentioning, that is looking at stream of commerce items in checkpoint CT, as you know. A lot of airports have now upgraded to those brand new CT scanners. The images are really good out of that, and we want to be able to give our TSOs all the tools that they have. So there are algorithms that detect guns, knife shops. Those are prohibited items. There are algorithms that do the complementary work like this, looking at those images. And eventually, we aim to be at a spot where the TSO can click a button that says stream of commerce, and they said that is a laptop with 94% accuracy. As we were going through the project, we realized that right now, all the algorithms run on the OEM machines, on the OEM scanners. So we need to figure out a way to decouple the algorithms from the scanners themselves. So the scanners can be an image generation device. So as we were going through the SVIP, SVIP was like, we know you guys can make algorithms, but we showed them the demo of the system that we had where we could take in the images and give the solutions out. And that's where this SVIP pivoted to the actual appliance. And that is the open architecture inference appliance that we have. We call it the Hyperator. That's requires a very high-speed networking. We have Exhibitor Systems here who is with us, who's working with us on a PCIe-based optical networking, so we can quickly gather the data and give the solution out. This enables the remote viewing side of the TSA roadmap as well. And right now, we are in phase 4 of that. This improves efficiency, increases passenger satisfaction, reduces that physical interaction, and it's open architecture based, so that it is compatible with a large number of scanners. Our second SVIP is what we call the securing soft target, is under that call. And Ron said our first use case was the leave behind, our abandoned baggage demo. So this is where you do not have security per se. It's not a hardened target, it's a soft target like a bus station, train station, between the curb and the gate at an airport. So what we built out as the end of phase 1, this is the output that you're seeing, is where we can track multiple people through a space with multiple objects. That's Dr. Monroe, who's our director of data science. He's actually going to take a bag out of another bag and hand it off to someone, and we can track that through an entire location. So we can do multi-camera, multi-object tracking. And none of this uses any facial recognition or any PII. So we are looking at other identifiable factors, and we can integrate it directly with video management systems so that, as you will see on the bottom screen, you will see that is the Genetec Omnicast, which is a VMS used by many surface transportation areas, that it will show out that, yep, that bag was abandoned out there. So eventually what we want to do is show this out in a place where Once this is ready to go, if a bag was abandoned, it will also say where the person came from and where the person who abandoned their bag is right now. It is open architecture compatible and works well with existing equipment. And finally, this improves human efficiency. This makes security proactive rather than reactive, because right now all our cameras are a forensic tool. We want to make sure that we can do it before it finishes, and it is compatible with existing equipment. And I promise this is my last slide. So we started off with the SVIP, and it was a very proud moment for us to sign a direct contract with CBP, which was 100 times bigger than our first SVIP call. So the SVIP today has helped us, Analytical AI, make the world a safer place. And that is our purpose and mission statement for the company, is making the world a safer place. Thank you.
On first. Hello.
Hello.
Well, thank you so much for that presentation. I really appreciate it. A few things stuck out to me. One being on the open architecture. That is just the hot topic of the week across DoD. That's all we're hearing about, is how do we future-proof a lot of the requirements to ensure that it doesn't matter whose stack it's built on, and it doesn't matter, you don't get vendor lock in those ways. So loved to hear that. So I'm just giving you props there. One thing so I had a brilliant introduction. We've worked with a lot of startup companies over the years, and I'm going to throw you a softball here because you didn't get to the call to action. You have a lot of folks in the room who you gave mad props to SVIP program and how you're doing more work at CBP, et cetera, but where are you trying to break into? Where are you trying to go? How are you getting there?
So today we have programs with AFWorks. So we got 2 direct to phase 2s with AFWorks. We have a program
which for everybody in the room means that if you're at DoD, you can do a sole source direct to phase 3 award with this company, just so you know. Okay.
And we work with Army. So the next generation MRAP has our AI on there for situational awareness. One project that's really close to my heart is our limited mobility SBIR phase 2, which is for TSA. That is for folks who are in wheelchairs. Today, they need to be patted down. And as you know, no one likes getting a pat down. And especially imagine being held up by 2 people because you cannot consent to standing in the AIT. So we are working with that. And we have again, at the CBP end, we have direct contracts where we are trying to stop fentanyl and bad stuff from coming into the country. So all of the stuff we do is, again, image-based AI. And we've been fortunate. We started with the passenger screening algorithm challenge. So there were folks like Dr. Fortune who were supporting us to break into this area. And we've been fortunate that we were able to break into this area. As you know, this area has a long acquisition cycle. So to stay viable in this area, you need to have support from that. So folks who are still imagining projects or dreaming about them, talk to the SBIR office and talk to SVIP.
Fantastic. Thank you.
Well done. Thank you for a great presentation. I'm curious about your automated threat recognition models, algorithms. Can you talk a little bit about how tightly coupled the algorithms are to the scanners, and how do you work around that? How does performance generalize across those? And what kinds of things can you do to improve that?
Yes, ma'am. Currently, our algorithms, the ones that are deployed, are on the OEM system itself. So we have to be very tightly coupled with the OEM, because today acquisition is as a system, a whole system. It's not a device separated from the software itself. So we tightly couple it with them. As part of the open architecture push, which the TSA has as well, there is a middleware which is known as the Open Platform Software Library, where third parties such as ourselves can come in and interface with that. The OEMs provide images which are DICOs, which is an offshoot of DICOM. As you know, in the medical world, it's compatible. It doesn't matter if your scan was taken on a GE Philips Siemens CT scanner. So on the TSA side, it doesn't matter if it was on an analogic IDSS, Smiths, or a Lido scanner. So it is compatible. There are some intricacies because of the scanners themselves. So we have to retune the algorithms. and then run it not on the OEM scanner, but on another appliance. And that is, again, a threat recognition server that the TSA is furnishing. Okay. Yeah. And
Thank you very much for that. Thank you very much for the presentation. And I think you hit on most, if not all, of the important points. I mean, obviously, DICO's compliance, open architecture, the OPSL, as well as the system development kit, all things that we're obviously very keen to keep pushing forward. So you mentioned about the interaction with the officers and the officers being able to work with the GUI application. What kind of feedback have you gotten so far about things that could be improved or things that we should be thinking about as we write requirements or specifications for those types of GUIs?
so right now our system is on the CBP side, and then that goes through the OEM. So the OEM builds the GUI. They do a lot of human factors testing. And I know on the TSA side, they are working on a common workstation viewer. So it doesn't matter which system your images are coming from, the interaction is going to be constant. So what we make sure is every output or every threat detection report we give out is consistent with that. And that goes on to the human factors on the other side. All right. Okay. Thank you.
Thomas?